Hello guys, this is Suhail. Welcome back to my channel, the channel where we simplify software engineering concepts. Today we are tackling one of the trickiest part of e-commerce app development, that is inventory management, right? So guys, by the end of this video, I'm sure you will know the different techniques to maintain the data consistency at inventory level, and trust me, this video is so much in detail. In short, we will be designing the complete inventory service along with all the trade-offs with nitty-gritty details. Although it looks like simple that we just need to do the inventory plus plus or inventory minus minus, but it is not. When you get into the nuances of implementing the system, you would realize, oh, I have to handle this way, oh, there is still a performance bottleneck, and much more. So guys, this would be the interesting video both for learners and also the guys who are preparing for interviews. So without wasting time, let's get started. So what would be our problem statement? Our problem statement is we need to manage inventory throughout the order fulfillment process, right? And what are the requirements for this particular problem statement? There should be high consistency in inventory management. For example, there could be thousands of users who are trying to uh, purchase the same product, who are clicking on buy now for the same product, right? But the product quantities are limited. For example, the product quantities are 10, but the people who are trying to purchase it, they are close to 500 or 10,000. So there is a very high contention here, and you need to make sure that no overselling or underselling of items should happen, right? Because if overselling or underselling of items happen, so you will craft bad user experience. So it won't uh, look good as respect to user, right? And the third requirement which we need to fulfill in this case, the inventory should be reserved for some time to allow user to make the payment. For example, you must have seen that you clicked on add to cart, and then then some of the items keep in the cart, and later then you check out the particular cart, and then you do the payment and other all stuff, right? So while doing the payment, there is some time, for example 5 minutes or 10 minutes, while you're doing the payment, so your inventory should be reserved. That that there is a high possibility that the payment would succeed, and the product would be uh, the item should be assigned to the user who is buying the product, right? So we need to maintain that as well. So what would be our agenda? Our agenda would be, we would be discussing different approaches to solve this problem, keeping in mind the latency. Because imagine if we don't keep the latency in mind, there are 10,000 users who are coming onto the application for buying the same product, but we can maintain the consistency, but we have to make sure that we should craft good user experience with low latency, right? And once you understand this complete system, the similar patterns, the similar approaches, you can apply in similar systems. For example, book my show, make my trip, irctc, tatkal, train booking, and these are very commonly asked questions. So let's dive in, right? So let's first discuss how the product details would be shown on UI. So this would be the general architecture. There would be client who would be calling the API servers, and it has the transactional database where, for example, the table is the products table. There, just for simplicity, just imagine there are three columns for this product table: ID, product name, quantity, and all, right? And obviously for fetching the product images, videos, description, or for the top selling products, all those details can be fetched from CDN. And for the rest of the products, the product details can be fetched from the cache. There could be Redis cache, or it could be your own customized cache, whatever cache you can choose, right? But just for one thing to sure, that the add to cart and buy now buttons should be enabled if the inventory is available, because that is real time. Otherwise, if you are showing add to no button, add to cart button and buy no button, right? So and later at the checkout stage the user will say, okay, there is no product, right? So it will craft a bad user experience. So what we have to do is we have to fetch the inventory in real time. So inventory has to be fetched in real time from the database or storage or any kind of storage, right? Because a lot of people are buying the product at the same time and the inventory keeps changing. There's a lot of high contention here. The products are limited, but imagine the users who are trying to buy the same product are, could be, for example, in this case the iPhone products quantity is 10, but the users, the buyers could be 500 or so, right? So we have to ensure that the add to cart and buy now buttons also should reflect in real time, and also that to make the data consistent with respect to inventory, right? So let's move further. Now, for example, in the last example we have seen, right? So we have the iPhone. There are 10 quantity for the iPhone, but let's assume in our use case the buyers are 10,000, and at same time every user clicks on buy now, right? What would happen? The resources are very limited, and the buyers are 10,000. There's a high contention here, right? So just before going to the approaches, before discussing for the approaches, one thing for sure, we need some kind of transactional behavior, right? Because to make data consistent we need operations to be in consistent order, right? We need atomicity, right? So we need kind of asset behavior. Now what kind of database this asset behavior supports? It is simple, the SQL database. Now imagine in the product table the ID, product name and quantity, right? This is the particular one row. For example, let's consider the example of this particular row. Now what everyone would think, okay, so to make sure or to ensure the asset properties, to ensure asset compliance, right? So for any transaction has to take an exclusive lock on this particular row with product ID, right? So what would be the simple query for this, for taking a lock on this particular query? Because later on the quantity has to be decreased once this lock has been acquired, right? Once the payment is completed. Now the simple database query could be, select star from products where id is equal to 1, that id for the iPhone, and for update, that is the main, that particular construct provides the exclusive lock on this row only. All the other rows will remain unaffected, but the lock would be acquired only on this row. And how many rows we need? Only the one row. So we have just applied the limit one as well. So this would be the simple query for acquiring the lock on this particular row. Now we have to make sure that this lock has to be acquired till the payment is not completed, right? Because otherwise if we keep the lock, or if we release the lock before doing the payment, this item could be uh, assigned to any other user. So we need to make sure that the particular lock has to be acquired till the payment not completed, right? Similar replacement of this database query you can easily do at the hibernate level. For example, with the at the rate lock annotation, you need pessimistic lock, right? Because user is quite pessimistic to acquire an item, for purchasing an item. So here we need a pessimistic, right? Because we need the quantity has to be decreased in a consistent fashion. Now let's discuss the limitations for this approach. Now limitations for this approach is, now as we have already seen, there is one particular row, right? And the buyers are 10,000, right? So what would happen? There's high contention only on this particular product, right? So what would happen? What is the limitation? That one request would go through, yes, but rest will have to wait, all the, for example, triple nine, right, users, that has to wait, and for those all those users there will be a long latency, right? And eventually what would happen? The low throughput, right? Now we need to make sure that we are decreasing the quantity only on payment success. So we have to acquire the lock for certain time period. For example, the lock has to be acquired for 5 minutes, right, or 15 minutes, whatever the config. This could be easily configurable, that 5 minutes or 15 minutes. So you need a lock for that particular time period, right? So keeping locks for long time can also cause deadlocks. So there are few limitations with this approaches, right? Now we are discussing more approaches for sure, but let's move further to discuss other things as well. Now before moving further, because this is also very important, I'll explain in the later section where it would come in picture. But before moving further, just understand the payment service integration. What would happen actually is, for example, it could be monolithic service or it could be microservice. If there is a monolithic service, you could have simple modules in an application. But let's assume we have a microservice architecture where there is a particular order service whose job is managing orders, and when the order gets created only on the payment success, right? Otherwise, there are different approaches. We'll discuss the all the trade-offs when we should create orders and all, but orders usually gets created only on payment success, that with the status, that with the particular status that this order has been created, and whether it has been shipped, delivered, where what are the stages are there. That is the job of order service. And the payment service, right? Payment service usually redirects to payment gateway, for example the payment, PayPal or Stripe. So what happens, how the integration happens, because this is also very important, because are you need to make sure that inventory has to be consistent after the payment as well, right? So that is why I'm discussing all these things, right? So payment gateway usually calls your application webhooks, right? So so when you see that once the payment is success, you see that the particular screen, once the payment is successful, that redirecting you in 5 seconds or 10 seconds, that this particular screen you usually see once you do the payment, right? So it simply means in 5 seconds, after 5 seconds they would be calling you web application hooks, what all the hooks you have provided to them. So for any system integration, there is a contract between two parties. So similar like here. So payment gateway would expose their own APIs to integrate, and also the as a client, if you have to use the payment gateway, you also have to expose some of the endpoints which the payment gateway would call on your side once the payment is successful or payment is failed, so that that after the payment is successful, that particular page is rendered with the complete details. So this is just one time activity when you generally integrating with any payment gateway. As a client, you use their APIs and they call your webhook APIs on payment success or payment failure. This is very important because on payment success and payment failure, you are doing so many things. There could be asynchronous or synchronous nature, that is completely on contract. But the main gist here is, on payment success you are manipulating the orders stage, and also you are manipulating the inventory minus minus has to be done only on the payment success. Otherwise, let's assume if the payment is failed, you need to roll back the inventory as well. So that is why this part is very very important. Now let's move further. So in approach 1, for consistency, we have used relational database or SQL database, for example the Postgres or MySQL, right? And we have used the exclusive locks. There are two types of locks: exclusive locks and the shared locks. But for high consistency, we only need the exclusive locks. Exclusive locks means that that row is particularly locked by a single transaction. No other transaction would be able to read or write on that particular row. For example, the row is 1 iPhone, right, and 10. So it is a single row, right? So on this particular row, only this one transaction can acquire a lock. All the other transactions would wait at the database side. This is all happening at the database side. Once the other transaction sees, okay, that is the lock already been acquired by some other transaction, the other transaction would wait. So let's discuss the trade-offs for this approach. Now, first trade-off, there's a very high contention. Still the problem is still on the same page, that the one row but the high contention, right? And so eventually the high latency, because 10,000 users are trying to buy the same iPhone, right? Now let's move further. Let's discuss about the databases, how the databases are built internally. Now all these databases are disk based databases, right, which uses B plus tree, and also the time complexity for operations are usually the order of log n in average case, right? But there are also retrieval and also updations. So just imagine the operation is still order of log n, but the contention is very high on this, right? Now if you are thinking to add replicas, then also don't work, because for example this is your one main instance and you add more replicas here, right? And you would argue that okay, now this would work. No, this also won't work. Why? Because there will always be a replication lag. Now if imagine, if you read from read replica, your consistency would be a toss, right? And because the write operations would always happen at the master, but you read from replica, and you read incorrect data. For high consistency, your read and write, right, has to be done from the master. Although there are some configurations that after for example, once you update the record, after 1 hour or so, there are configurations that after then the transaction is eligible to read from the replica. That custom logic, although you can build, but still for the same time, that the contention would be on the same database, right? So read and write on the same row, then the latency is very high. All the other requests would wait. Now let's move further. Now, yeah, let's discuss the approach 2. We have already discussed the approach 1, what we have discussed there at the disk based databases. We are using the MySQL or Postgres, right? Now there are few observations which we need to observe over here. Now what was the main problem? Contention on the same product ID row, just for operation quantity minus minus or quantity plus plus. Quantity minus minus when it should have happened correctly when the payment is success, and quantity plus plus then the payment is failure, then we have to roll back the inventory. So that is the main operation. And also we are showing the add to cart and buy now button in real time based on the inventory, right? So these were the main problems. Now just before making the implementation, or before going further, let's assume we need to design something similar in Java, for example, in a single process. Why, what how we would design? Same, just we would design, this is a kind of counter we need actually. If we see, this is a kind of counter, that this counter has to be incremented or decremented atomically. So we need something similar to atomic integer in Java. This is what we need eventually, because for making the inventory consistent, this is all we need, right? So atomic integer supports increment decrement operations in memory, right, without without overhead on application by taking logs. So application is not taking logs or anything. Atomic integer is just a pure highly scalable counter which can be easily used in Java. Similar kind of data structures would be available in other languages as well. Now similar kind of thing we need in this distributed e-commerce system, right? There could be multiple instances of product service, but we need similar kind of atomic integer. How we can do that? There is one thing: either you can build your own cache, or you can use the inbuilt cache, which is already been built and ready for use. That's it. Now we need to no, we are sure that we need to all support all the operations in memory, because this is lightning fast, right? So plus plus minus minus, we need to support all these operations in the memory, but that too atomically. So what is our solution? So either build your own custom cache, or use Redis cache to support all these operations, right? You can build your own custom cache using this particular concurrent data structures, for example, the atomic integer and atomic, all the atomic data structures or which are available. Or you can use the Redis cache, which is highly optimized for storage as well as highly optimized for, and this a well proved cache actually, which is being most widely used in industry, right? Either you can build your own custom cache, depends on use case, depends on the uh, stakeholders, you can take a decision. But this is what we are sure, that we need to fetch the inventory also from the cache. Now the another problem would come up, okay, how we ensure that this particular cache inconsistent with the database table? That is a separate thing which we would look into later. But just for now, for real-time inventory, we need something which can be lightning fast and that can be retrieved from cache. So we can use this custom cache or Redis cache. Now let's move further. Now let's discuss how we would implement. We have already discussed that we came to a conclusion that we need to somehow use the cache, but how we would use the cache, and how we would support these operations. Now Redis already provides this increment, decrement, increment by, decrement by. These are all operations which are already provided by the Redis. Now what we would have to store eventually in this kind of storage, in memory storage, we need to store in key value pair, right? We need to store in key value pair. What if we can create key like this? For example, the product id and the original inventory. For example, product id is this one, the original inventory, this would be the key, right? This would be the key and the value would be 10, right? So this would be the key and value pair. Now since we have to support add to cart button also in real time, along with functionality of holding the lock on item till the payment is done, so this can easily be done, right? Because now we have stored the key like this, right? Now but what we discuss, we need to ensure that this particular inventory has to be reserved, has to be blocked till the payment is not done. So what, how we can do optimally in this way? We can just create one more key with the product id, and this would be the different key, product id reserved inventory, this would be a different key, right? Now let's see add to cart or buy now enable functionality, the how this button would be enabled. That's a simple calculation, that origin inventory minus reserved inventory should be greater than equal to 1, right? If that is the case, that means our add to cart or buy now button should be enabled, because now it is lightning fast. Because imagine if we don't keep this key, if we don't keep this key and we directly starting doing the decrement operation here, it would be a challenging part. We need to maintain so many things, right? So it's better that we need to untouch the original inventory. Instead of that, we should create one more key with the reserved inventory, right? So when it would be created, this key would be populated when the user clicks on checkout. When the particular order has been checked out, only then this particular key has to be populated, right? Otherwise it is okay, to keep the to not keep the reserved inventory, right? So this key would be populated once the user clicks on the checkout part. So our add to cart functionality is very very simple now, just one if condition for this, right? Now let's continue. Now our add to cart problem already solved. Now second problem, what was there? The high contention on the product ID row. Now this also we have discussed that okay, we need to somehow support the increment or decrement operations atomically, right? Now either you can build your own custom cache, or in the custom cache you can build the own method, okay? That for example, there is a custom cache, you can uh, create your own method in that custom cache that could be called by each and every product instance as in when the products are being or orders are being checked out. Or you can simply write a redis lua script. For example, the product ID is this one, the reserved inventory is this one, right? The original inventory is this one. We are just calling the get operations, and we are just doing the if the original inventory is greater than reserved quantity, right? Then it would increment the reserved inventory on the checkout part, right? And it would increment the reserved inventory, right? And it would return okay that the inventory is still available, that add to cart button is has to be enabled, and or at not add to cart, that the inventory is still available, user can proceed with the checkout. Otherwise the checkout would be blocked, right? Because if this failed, the checkout at the checkout stage only the user would see okay, thus this item is not available. In that case the uh, user has to remove that particular item from the cart. Dead simple, right? It's very very simple thing, right? Now what are the pros for this approach? Now since all these operations are from memory, right, low latency, since we are using the key value pair order of one operation, now it because we are using in memory, it is lightning fast, very very fast operations. So this is how we can solve this particular problem. Now let's move further. Now what would be the final flow? Now we are slowly going into the nitty gritty details for each and every step, right? Now for example, this what would be the final flow? User comes on to the e-commerce app, he has clicked on add to cart, after then he has clicked on checkout, right? On after that checkout, what would happen? On checkout itself we would reserve the inventory, because at this stage only we need to reserve the inventory, not on the add to cart or buy now button. At this stage what would happen here, the again the check would be marked okay, all the items are still available or not. If any of the items are not available, the message would be shown onto the UI screen that this item is particularly not available. Then once the user clicks on checkout, he'll redirect it to the payment uh, gateway, right, where he'll do the payment and other stuff. But this is where the inventory would be reserved. Now when the orders would be created, now we have seen that at this stage the inventory would be reserved, but for some time, for example reserved for 5 minutes or 15 minutes, right? But when the order would be created on payment success or before payment, this is a important question, right? So when would the order would be created? Now let's discuss this part. If you create the order before payment, your tables would be, for example, let's assume there is already a table, orders table. There's a few columns there: user ID, order date, payment method, status, could be shipped, could be pending, could be anything, right? Now assuming we are keeping orders in orders table for 6 months, right? Now orders older than 6 months has to be moved to cheap storage or archive, but still the 6 months orders are still there. Imagine now, before payment, if you are creating the orders, right, the orders table would keep on growing, right? Now let's imagine if the payment gateway maintenance going on for 1 hour or so, if the payment gateway is down, but what would happen? Your orders table would grow like anything, right? It would be much huge, and already it has so many records with the status success, shipped, delivered, what all the things are there. But now what you are storing? You are storing the in process orders as well, for all the orders whose payment is not completed yet. So you need to maintain these orders as well, right? So there's a big problem here, because you are now impacting the other order as well, because this table would grow like anything, right? Now, so all the failed orders also has to be purged. For example, let's assume the payment has been failed, right now, and you have already make the entry in the orders table. Now what would happen? What would you do? Actually, you need to or either soft delete those particular orders, or you can do the hard delete. But you still has to do the purging at some time. Sooner or later you still has to do the purging for all those orders, right? Now there is a possibility of rebalancing B plus tree, because there are so many failed orders are there, right? So if you hard delete that particular order, then it would impact the others orders as well, other rows as well. The performance would be degraded. So let's assume we are uh, creating the orders on payment success only. Okay, if we are creating the payments on if we are creating the orders on payment success only, how would we maintain the order state? Now there's a better solution for this. Create a temporary orders table. For example, the order staging, all the orders till the payment not completed stored in this table. So what are the pros for this? The less data, low latency, all the failed orders can be retrieved easily, the fast retrieval for these orders. The purging would be fast, right? For example, you can have a purging logic for example, you can create partition on order date, and you can have a cron script that runs typically, for example, 12 o'clock, which will purge all the which would purge the complete partition. That's all, your job is done. So that's the very important decision. Now, now if the payment is failed, you need to audit the order as well. Now you already have the order here. You can use this order for anything. You can your monitoring or customer team can call that particular user. Oh, your payment is not succeeded. You can still try to book the order. That's how we usually retrieve the phone calls, right? So you can keep the orders in this table for monitoring and for customer team to look at these orders, what happens with this, right? But if your payment is failed, but one thing is for sure, you need to roll back the inventory so that it has to be available for other users, right? Now let's move further. But that's all, I believe. Otherwise the video would be much longer. So we'll conclude this video with this topic here. But I'll make the part 2 for this video. Now there are still things which are left, which I'll be discussing in next video. The order timeout, if the payment not completed within time, maintaining the real inventory in products table in SQL database. Because imagine you have Redis, right? But Redis also has to populate data from somewhere. For example, this is the transaction database. Redis also has to populate from data from this database. Now imagine all the new ongoing products, they can't hit directly the Redis, right? There has to be some storage where those product actual quantities would be stored. So Redis has to populate from this particular database. So, and also we'll discuss the complete architecture with respect to inventory and with respect to orders as well. So see you in next video. This is part 2 of this inventory management in e-commerce applications. Just a small request, this is the prerequisite for this part 2 is you have to watch the part 1 video that is already I have published on YouTube. You just watch the part 1 for this consistency of inventory management in this e-commerce application. In part 1 we have discussed very interesting things. Firstly, we discussed what type of database we can use to avoid high contention. Particularly, there we have seen an example of an iPhone where the quantities were only 10, but the buyers were close to 10,000. So there was very high contention there. So we discussed all the trade-offs, the pros cons of different types of databases, and finally we went with the cache for maintaining the inventory. This cache could be your customized own cache, or it could be Redis cache, right? Then finally we discussed when and where the order should be created. Orders should be created before payment or after payment success. There we have discussed the pros and cons for this both approaches, and we have seen when actually the orders should be created. But after discussing all the trade-offs, all the things, we finally went with the temporary table, that is order staging for maintaining the orders till the payment is done. And what were the benefits for doing that? That purging of those orders would be efficient, because if we maintain these kind of orders also in the actual orders table, that actual order table would grow in size and it would impact the performance. So in this case what we can do is, that is it, we know that this table would be storing the temporary orders for those orders till the payment is in process. Now the purging of these failed orders, let's assume if the payment failed due to any reason, the purging of these orders is efficient. We can do the partition based on date, and the cron job can simply run at the end of the day and can simply delete the partition. So we don't need to delete the row one by one, we can just purge the complete partition in one shot. So it is more efficient. We have discussed all these things. Now let's move for part 2, what all things were pending. So we'll be discussing in this part 2. So firstly, let's see the complete architecture post payment. What would be our steps once the payment is done, right? So this is the complete architecture, the post payment. Usually what happens is, payment gateway invokes webhooks once the payment is done, right? That is also we have already discussed, right, in the part 1. Payment gateway would invoke the webhooks, and let's assume we have exposed the order service API as a part of webhook to them. So they will call this webhook, and what we will do as a client will create an entry in orders table, right? We'll create an entry of order in the orders table, right? Now because the staging order would be deleted and the actual row would be created in the main orders table, right? Because now the order is no more temporary, because the payment is completed and we are sure that order has to be processed, right? So we create an entry in the orders table. Now what else we do as a part of this? Now there are kind of other services also, or other modules who has to perform some action once the order is placed. For example, the shipping service, for example the analytics service. Analytics service could be like how many orders processed per day. The shipping service has to take some action. They have to they have to pass this order to logistics and all. Similarly, there could be other messages which we need to send. Now let's see what kind of messages we would be publishing to Kafka. That's already we discussed the order update, and particularly order ID, date, status, and the partition key. What we will use is the order ID. That's all right. Now apart from this order update, what all messages we need to send? The other message is the product update. Why this is necessary? This product update is actually the all the product details which are available in the order. For example, in one order, this is the product detail, product ID 1 and quantity 2. This is what the buyer has purchased, right? So what we will do is, we will update the product, we will send the product update message. This is a very simple kind of we will send the product. For example, let's assume there is an order, right? And in this order there are two products, product 1, product 2, and its quantity is 2, its quantity is 10. For example, this is the state of this order. So what we will do is we will send two messages, right? We will send two messages, product id 1 separate, then product for 2 separate. Now we'll see why we are doing this way, because there are some benefits for this, and the partition key would be the product id. Product purchased in the order would be sent individually as an individual message partitioned by product id. Now let's see the benefits for this kind of message, because this is very much important to make the inventory consistent, because this is when we have to reduce the actual inventory, because this is when we are sure the actual inventory is reduced, right? So this is when we need to store this, or we need to update the redis cache as well. Now let's see what are the advantages by doing this. So let's see why product update needs to be sent separately. Why not a part of order update? There are some benefits for this. First benefit is the performance benefit. For example, here we can easily apply the batching. How? Now product service can easily consume messages in batches. Now, for example, we have already sent partition key by product id. Now we know in a particular broker, right, product id 1, that this particular broker would be receiving, and product id 2, this particular broker is receiving. Now product service can simply consume all these messages in one go, because it is sure, product service is sure that with id 1 would be sent on the same broker, right? Now product service can easily consume the messages in batches. For example, 20 to 30 messages. This also can be configured, group by product id, and can simply update the count. For example, there are 10 messages for the product id, right? Product id 1, quantity 2. Similarly, there is one more message, product id 1, quantity 3. This message could be part of order 1, this message could be part of order 2. We are not worried, because we are sending the product messages separately. Now what we will do, product service will club all these messages, product id 1, and total count, what it is, total count is 2 plus 3, it would be 5. So the product service can easily batch all those messages and can update the count directly in redis, and also in the main products table in the actual database. So it is lightning fast. Just we are not doing the count minus minus anymore. We are just doing the count minus count equal to count minus n. So this is the benefit which we are getting from this approach. So that is why we are choosing this way. And finally, we will commit to Kafka. This is very fast. This is how we will make the inventory consistent on payment success. Now we have discussed this thing as well. Now let's discuss the order timeout. The remaining thing, the last pending thing is the order timeout. What would happen if the payment not completed in a configured time, right? Now when the payment is in process, we already made the entry in order staging table that we already discussed, right? For example, this is the order timeout update message. Now let me explain that this is the order service. As soon as we'll make the entry in this temporary table, we'll send a particular job schedule kind of message in this Kafka as well, right? Now there are worker threads, background worker threads, whose job is to update the inventory in redis cache only, right? In redis cache only, because we don't need to update in the main db, because this is just a temporary order which has been failed due to timeout, or due to payment not failed, or due to any xyz reason, right? Now these background workers could be in product service or could be a part of separate service. These background workers can directly update the redis, right, with the very simple operation, for example the decrement by operation, and or decrement operation, that is the particular key which we have already discussed, 1 minus reserved inventory, right, and decrement by n. For example, in this particular order, the product id 1, right, and its quantity is reduced, these three quantities were there, for example, right. So what would happen here is simply decrement by, this is the key which we have already discussed in the part 1. This is the product id with the combination of this reserved inventory. We discussed all this in part 1. So we'll simply apply the decrement by function, and we'll directly decremented all the count of these products who are failed in this order by just one operation. That is also very fast, and we have done this operation atomically. Now this is that simple. If the order status does not change to confirmed, reserved inventory would be reduced, right. This is what we have done here. The order timeout update message, what when it would be sent, as and when the orders entry is created in the order staging table. When this entry would be created in this table, on the at the checkout click button, when user clicks on checkout, this entry would be created, and this also message would be sent. The background workers would see the time for this, and would see the configure time, for example this time, and the configure time, payment configure time, payment timeout configure time, right, payment timeout configure time. If this timeout time is greater than this particular date, then the background workers would execute this particular job and would mark the order, would decrement the inventory of that particular product. So that is how we would make the order timeout as well, till the payment is not till the payment is in till the payment is in process. So but still there are few edge cases. Let's assume if payment response webhooks not received in a certain period. Let's assume there is a latency at the payment application, right, and we did not receive the webhook message. No, what would happen? Our background workers are still in action. They would keep running, and they would keep checking that particular time, the payout configure time minus the order place time. So they would keep checking that, right. If that time interval is greater than the, for example, the payout configure time, then those workers would decrement the product inventory count, right. That's what all we discuss. Now that is what, when the payment gateway actually invokes the webhook, right. So at this point of time, the order service would send in the response that the order is already timeout, the order is already timeout. That is when you see sometime the messages on mobile that payment deducted, then suddenly you see the payment credited as well immediately, and sometimes you see the message payment deducted, amount would be refunded in some time, right. So that's how your orders, inventory, and payment services doing action behind the scenes. And you can see the inventory data is so much critical, right, for users, right. So that's all for this video. So thanks for watching this video. So if you really like my explanation, please do watch other videos, and subscribe my channel. We'll see you in next video. Thanks a lot. Thanks.